Hi, I'm Maria Ingold. Welcome to AROS. Academic research requires what is known as robust evidence synthesis, which means comprehensive evidence has been gathered, but that data is spread across at least 28 search systems. Comprehensive requires searching all the research. Using a simple reflex agent, academic research online system AROS is a first step towards that. This project is based on our AROS team report. At this stage, AROS is very simple. It only focuses on web scraping. It is built in Python because Python is well supported and readable, with a range of libraries. To evaluate libraries, I wrote 2 very basic scripts during the team report, covering all 4 stages: collect, extract, transform, and store. These are in my ePortfolio. I decided not to proceed with Scrapy, even though it's one library, faster, and for medium-scale projects. I selected requests, Beautiful Soup 4, and Pandas, as they're more suitable for beginners, which I am, and small projects, which this is. I refer to that early prototype script as version 0.1. I started with code from a NIGAM and BSWAS 2021 research paper. The first thing I discovered was that it didn't work. I used Beautiful Soup to print the page text. While the code in their paper obviously once worked, Yahoo now returns an error page. We'll be right back. It says, nothing Terminator about that. Other sites behave similarly. I finally found that arXiv.org returned its web page. This specific page is one of my test pages. Note that it is on web scraping. By looking at the source code, I was able to identify citation data. This seemed like a simple, useful starting point. Version 0.1 simply parses a hard-coded page. It takes the citation metadata within the page, title, multiple authors, and date, and writes it to a CSV, comma-separated value file. It works, but it's very much a prototype. I'm a strategy and innovation CTO. I last programmed 20 years ago, so I've kept this simple. But there were several areas I wanted to address in my second version. Firstly, to increase modularity. In other words, logically separate each task and simplify maintenance. I moved from a script to a class. I was initially going to create 4 classes. However, I discovered that a primary tenet of Python is choose simplicity over complexity, especially with classes with a single method. So I created an arXiv scraper class with 4 methods instead: collect, extract, transform, and store. Secondly, to improve flexibility, I eliminated my hard-coded URL and pass it as a parameter. This is used by requests to get the page content. Thirdly, to better facilitate search in my next version, I also extracted abstract. This is in addition to the title, authors, and date, all extracted by Beautiful Soup 4. It transforms the data into a Python dictionary, converts it to a Pandas data frame, and uses Pandas to store it as a CSV file. I tested version 0.2's core functionality along the way with print statements to verify output and by successfully outputting the data to a CSV file. To make the class a simple reflex agent, it needs to receive sensory data from an environment, decide what to do, then act on the environment. The third version of AROS receives a URL and keyword or phrase, collects the URL, and extracts the required data. That is the sensor. It then decides if that keyword is present in the title or abstract, and if so, transforms the data. It acts on the environment by storing the result in a CSV file. The main changes to the code are adding a decide relevance method and a run method. Decide relevance uses a delightfully simple membership operator in to find a substring. That is, it finds the keyword in either the title or abstract that was just added in version 0.2. Run then collects and extracts the citation data, tries to find the keyword, and if the paper is relevant, notifies the researcher and writes the citation data to a CSV file. Otherwise, it states that it is not relevant and does not store the file. In version 0.3, this occurs for both if it is not relevant and if the page is not found. Version 0.4 addresses this. Before I get on to the final version, I want to talk about testing. I used a Prince2 Agile approach. I thought through the big picture in a planning stage for our team report and implemented it iteratively for this individual project. I got each component to work, and I slowly built the functionality. As you've seen, I first performed basic unit testing. Does each component work correctly? I tested every step with print statements and then ran code after every change. Similarly, with integration testing, do the modules work together as expected? And functional testing, does it deliver my requirements, my print statements, and the CSV file? At every version, I had to perform a basic smoke and regression test. Did it still work as expected? But this was all manual. This was decidedly not DevOps, CI/CD, continuous integration, delivery, and deployment. To get closer to that, I needed two key things: version control, I'm using GitHub, and automation. Automated unit testing in Python is provided by UnitTest and PyTest. In version 0.4, I selected PyTest because it worked and it is more succinct. This is the PyTest code using a good arXiv URL. Each test tests a method in the arXiv scraper class. These are basic unit tests. Does the method work correctly, rather than a comprehensive functional test? These tests can be run all at once or one at a time in any order. As you can see by the 100% and green tick boxes, they all passed. However, PyTest raises a deprecation warning in one of the libraries. I have updated all the libraries to the latest version, and it still appears. My guess is the library, possibly Pandas, has not been updated yet. One other thing you can just see here is that I have created the potential to pass multiple URLs in version 0.4, not just a single URL.
This is AROS version 0.4. I've added the ability to input multiple URLs. You're welcome to add more here. In the run command, you can add the keyword or phrase and the output file name to store any relevant search results. I've also added some basic error handling around the URL. If I run AROS, the first URL will fail because it's not an arXiv URL. The second will fail because it's incomplete. The third and fourth will either find the provided keyword relevant or not relevant. If the keyword is relevant, the citation, title, authors, date, and abstract are displayed and written to a CSV file. The third URL will find artificial intelligence. And the fourth will find web scraping. Errors and explanations are provided if the phrases are not found. You can see that the CSV files have been written to the current folder. They're in the same format you've already seen. This is the code. The libraries, the archive scraper class, initialization, collecting, get the page content, or return an error using requests. Extract the citation title, authors, date, and abstract using beautiful soup form, and store it in a Python dictionary. Transform the dictionary to a pandas data frame, and use pandas to store the data frame in a CSV file. Relevance is decided by finding the keyword in the title or abstract. And if it's a valid URL, run rinse the results or notes if it's not relevant. There we are, AROS version 0.4.
Versions 0.1 through 0.4 look like this. To move towards a production-ready version 1.0 requires a range of other actions. Technically, for scalability, performance, and medium-sized projects, Scrapy is better. It can also handle web crawling pages instead of a URL list, and can schedule crawling during non-peak hours or rate limit. By default, the latest versions of Scrapy respect robot.txt policies. Mechanical Soup and Selenium can provide interaction and automated browsing. Beautiful Soup handles small, static HTML sites, but Selenium is required for dynamic web pages with JavaScript. To become a more sophisticated intelligent agent, search relevance can be increased with natural language processing, NLP, using the Natural Language Toolkit, NLTK. Storing it in a database instead of a CSV file would enable persistent storage and permit more complex queries and analysis. Of course, a graphical user interface to enter search terms and view results would improve the experience. As the service extends, more error handling will be required. For robustness, more tests for performance, security, and compatibility will also be needed. Automated testing, where possible, will help create a CI/CD workflow. For ethical and legal compliance, Scrapy has more built-in capabilities, like robots.txt middleware to respect robots.txt. However, it does not address all the issues. It might be worth exploring Common Crawl, a free, open web crawl data repository containing over 3 billion compliant pages. It means pages would not be hit unnecessarily, which would also improve sustainability. In conclusion, we have discussed how, over 4 versions, I have built up from a simple web scraping script to a modular, simple reflex agent, which finds a keyword or phrase in arXiv citation data. Several URLs were tested. Errors were caught and reported back to the user. Title and abstract citation data from valid arXiv URLs were checked against the keywords for relevance, and relevant citations were displayed and written to a CSV file. As a step toward automated testing, PyTest was used for unit testing. Moving towards a 1.0 product would require moving to Scrapy, evolving with NLTK, and considering ethical, legal, and sustainable approaches through Scrapey and perhaps Common Crawl. The code is available in GitHub. Please check it out. Thank you.